All right, here we go. And good morning. It is time for episode 10 of Cosmic Matters. We do this every Sunday, 10 a.m. to 11:30, 12 o'clock. And today's Cosmic Matters is going to be talking about the size of the universe. I was going to have a guest or two today, but we'll see if they show up. If not, we will just continue on the way we're going. And one of the things that I love, well, let me just start off by saying, thank you for taking the time to take a look at this matters to join me today. Actually, let me see. No wonder I'm so dark. I need my lights on. I need some photons. And as far as I started doing these videos, by the way, it's called Cosmic Matters. I'm Matt of the Matters. And, and I created the Matters videos just to start having people have a different perspective, have a different talk, start talking about things on a grander scale, as opposed to getting wrapped up in our daily activities, which obviously do happen. We have our daily activities, we have our daily lives. But my objective is to become a full-time content creator. And one of the things that they've said you have to do is be consistent. So we're on episode 10. And one of the things I love talking about is space and philosophy. Henceforth, my name is, as I titled myself, Philosophy Man, right? I was a philosophy major in college. And the concepts of, space and science come together, and philosophy and science, it comes together in many ways. And my worldview, one of the things I take a lot of pride in is that my worldview on, let's say, like life and like God and existence and everything matches up with science. Like, it's not instead of science, it's not in spite of science. It's not like, well, you have to believe these things and science disagrees with it. This is one of the reasons why, and understanding what science is, like, I don't even think many people understand what science is. Science is just it's just a way to study the physical world. Like, it's just looking at what we're doing, and I always say, like, the first scientists were religious people. The reason we made gods everything, maybe we had, Poseidon and who, the god of the ocean, and Hermes, the messenger god, and Apollo bringing the sun across the sky. The reason we had all these gods is because we just didn't understand. We had no other explanation. And humans really love understanding things. We don't like dealing with, I don't know. The idea and the concept of we don't know why something happens. We'd rather make up a fake answer than actually just sit around with, I don't know. And this is not just back in the old days. We do this even today. I've seen people, hey, what's up, cringe face? I've seen people who literally will say, well, science can't explain this. And I'm like, okay. And does that mean you can just make up whatever story you want and attribute it to, whatever God you want to attribute it to? Like, this is like, that's not how it works. We're allowed to say, we don't know yet. And the universe is never going to know. And when I say the universe, I'm including me and you and everyone else who's listening. We're never going to know everything. Like, that's the whole point. The point is to discover things. The point is to search and find. I always say, if you believe that you already know the truth, how could you be a truth-seeking being, right? Like, because you already know, right? So the point being is if you already know, and then there's any evidence in contradiction to the things that you purportedly know, then you're going to dismiss it because of the fact that you already know the answer. And why did I get disconnected? Okay, there we go. We're back. So the concepts of things that I like to talk about is searching these hard questions. And one of the points of this particular podcast is just talking about the actual size of what things are, like what's out there and how big it is. And when we look at the earth and we say we take things and we put them in perspective of ourselves, right? Something that's big is and small. We're going to talk about the big and the small today, the size of things. It's big and small based upon perspective, our perspective, right? We already have a message coming in from our stereo audience. Let's see if I can get that to play. Let's see how this works. Oop, I got to turn the volume up.
Is known as the god of gaps, and also the aliens are gaps now, because it's all been updated. So when people look in the sky and see something they don't understand, they immediately say, "Oh, well, it must be God."
Battery 60%.
Or,
Call ended. Call ended.
Yeah, that's not working. Yeah, absolutely. God of the gaps. That's what Neil deGrasse Tyson did a talk about. Well, he had a statement saying that if you put God, a lot of people, they'll put God into places of unknown knowledge, right? Unknown things. And then he says, if you do that though, then your God is a receding pocket of our misunderstanding, our missing knowledge. I forget. I've already butchered the quote. Right? Oh, okay. I guess I can't have this on here. TikTok is very mad because I'm using a picture. All right. Interesting. All right, so then we'll stop the live. And there we go. All right, we're going to leave TikTok. So anyway, the point being is yeah, and so this concept of how big things are and how small things are is all relative. Everything is relative to us. To me, being a 6'3" man, if I see my ex-girlfriend was 4'11", she was small, right? If I met Shaquille O'Neal, he would be tall, but that's just in perspective to me. In perspective to Earth, certain things are bigger or smaller. In perspective to the sun, it's bigger and smaller. In perspective to, but when you get to like the universe, when you get to understanding, and that's what we're going to do a little bit today, when you look at how big things are and how small things are in an infinite amount of space, right? You get to the point where you say, what is big or small? What does it even mean anymore? Because it's crazy to think about, as we go through and we explore this stuff. So I'm thinking about what I'm going to be talking about a little bit, and so that's why it's hard for me to come up with words properly at this moment as I get started with the day. Piss poor. I don't know why my speaker won't connect properly.
Battery 60%.
Let me see if it will.
Call ended.
And for some reason, let me
Call
do that.
ended.
Let me do this. And let's restart it. That's not working either. All right. So unfortunately, these messages are not coming in very clear. So, but I'll listen to them and then I'll restate them.
Yeah, I heard the same thing from Grassy Tyson as well, where he actually, he says that what's needed is more data. Until I've got more data, I'm not going to say that I know what it is. That's what basically is just. He pointed out that it was Isaac Newton that couldn't understand how the pull of Jupiter affected the Earth, and that the Earth's orbit still remained pretty much the same and wasn't pulled out by Jupiter every time they coincided. So yeah, Newton at first thought, well, it must be down to God. Obviously, he was a man of science and the Enlightenment, but he eventually it was solved. The mystery was solved through further research and all the rest of it. So
Yeah, and the point is, you're always going to have. But if you want to look up something interesting, look up the three body problem, yeah, and why. Like, as far as when you have gravitational pulls and you have two things, it's very easy to explain. When you get to the third object, it becomes very confusing to understand orbits and how gravity affects three things, right? So but yeah, it's when we get to the point of when we get to the end of our understanding, then um we kind of start invoking gods, right? Gods or the unknown, or we don't have to use the word god, it can be anything, people, aliens, right? Like and it's just challenging for many people to just be like, well, we just don't know. How about we just don't know? And we'll just try to find out, and that's what we need. Maybe we just need more time. We need better math, we need better science, we need better observations, we need smarter people, and that's how we discover more things. So getting to our topic today, understanding the size of the universe and just how big things are, because we say things all the time. We say words that, and I do this every Cosmic Matters. I do the same analogy, or perspective. It's not really an analogy, but understanding like things like millions and billions and trillions, and how big this actual universe is, because we look in the sky and we see all the stars and we're like, oh, they're out there. We understand they're far away, but we don't really understand how far away. And we don't like to spend a lot of time thinking about it, because for some reason, it makes us feel small based upon how big the universe is. And it shouldn't really. I mean, it's just because it makes us feel almost insignificant, right? But if you think about it, I'm going to pull up this picture, and by the way, just so everyone knows, I'm not on TikTok anymore, because TikTok gets mad if I use any pictures that are not like I didn't draw myself, but which I don't understand, because they have people playing video games all the time. So, but you can check me out if you want to see the videos or the images that I'm playing. They're on. You can check them out on Cosmic Matters on Spotify, or you can check it on YouTube. It's just where we are right now, live. So, but here's a mosaic of, it's a picture of an eye, but it's made up of 10,000 pictures, 10,000 small pictures that make up an eye. I think we've all seen pictures like this, mosaics like this, where you zoom in and it's all these little pictures of people or whatnot, and when you zoom out, it makes a bigger picture, it makes a grander picture. And so when we think of the universe, I think of this whole thing, it all depends on your level of magnification. Like when we talk about you as a person, what are you? Aren't you just made up of cells? You're made up of skin cells, blood cells, and neurons. As far as your, why can't I think of the word? I can't think of the word. I'm having trouble thinking this morning. But anyway, your nervous system, right? So you're made up of just trillions and trillions of cells. And actually, I actually did this thing about the human body, and there are around 75 trillion cells in your body. So every single cell aren't those all very small, and aren't those all inconsequential? But no, but on a grander scale, that's you. You need all those cells. Now, if one cell died, are you going to die? No. But if enough of them die, right? But every single one is comprises you. It makes you who you are. So every single thing, every star, every tiny atom in the universe is important to the whole of the universe. I always talk about the Zeno's paradoxes. Last week I talked about this one as well, but I'll bring it up again. And it's what's called the paradox of the heap. And the paradox of the heap is, if you have one grain of sand, you do not have a heap of sand, right? And if you add another grain of sand, you still don't have a heap of sand. We would just call that 2 grains of sand. And so the idea is henceforth, based on that logic, adding 1 grain of sand does not create a heap, right? But if you keep adding a grain of sand and another grain of sand and another grain of sand, eventually you will have a heap. right? But now we don't know which particular grain of sand something a heap of sand. Like there's no definition. Like okay, when you have 13,426 grains of sand, you now have a heap. All right, so you could take one out and you would still say I have a heap of sand. You could add one more and you'd still have a heap of sand. But the concept is so vague as to what is a heap, what is so the individual parts, every single one is important to create the whole. And so, but if one part was taken out, it's not like the whole dies, but they're all important. They all make up what is necessary. So when we think of the small in our own bodies, all these little cells are necessary to make us. But what is us? We're the heap, right? Like what do we actually mean by us? And this was our entire last show was talking about, who are you and what do you mean when you talk about you? So and even we talked about last week again is I did some factoids checking, but I just told you there's 75 trillion cells in the human body, but only 34.6 of them ish, we're getting ish, are actually have human DNA. So less than half of your body cells are human DNA, right? And we get so wrapped up in human DNA when we talk about like abortion and all this stuff, like, oh, it's you got to be a human, but most of you is not human. Most of you is not human DNA. Most of you is bacterial microbes and all this other stuff that makes up you, but you call it you, right? And so, but you couldn't live without all that other stuff, right? So when you go down to the very small, all these things going on, the conflicts, but if you looked in your blood and you looked at what's going on in your body at all the time, it would be mass chaos. It would be all kinds of strife and battles and things eating other things, and this is all you would see. So when we talk about on this level of magnification for us, we talk about the wars that we have and the fighting that we have, the left versus the right, and all the conflict we have already on our planet. We're like, oh, why can't we just be world peace? I mean, maybe world peace is not what's necessary. Maybe the battles and the conflict that we have on this level of magnification is the universe being healthy at a bigger level of magnification. All right, when you look at that, all these stars, like the immense amount of power and things that are going on. When you look into like black holes, that are eating up and churning out all these things, and quasars and neutron gamma explosions and all this stuff. Maybe all this release of energy and adding of energy, and all this is necessary for the universe to exist on a higher level, for it to be the consciousness that is all of us. So when we talk about how big things are in a couple of seconds, don't make it so don't personalize it to wow, we're so insignificant, because we aren't insignificant. We're a part of the whole thing. We're the water molecule in the river, and the river in itself, every whole thing is its parts, right? So that's why I had the mosaic of the eye, because you couldn't see this eye if all of a sudden you started losing parts of if you started taking off pictures. Actually, if you took off one picture from this thing, it would look a little weird. You'd be like, why is there that white spot right there? So all right, so let's dive into it. So I want to start off with, let's see which video we're going to start with here. Let's remove that one, and let's go to this one. Yes, okay. So, and you can watch this video on YouTube. It's a YouTube video. It's called the universe size comparison in 3D. So I'll for one of our stereo friends, I'll kind of explain what's going on here. I'm going to start playing the video, and it starts off with series. Moon of something. I want to say of Mars. Let me look it up real quick. CERES is what I'm talking about. Let's see what it actually is, the moon of, because that's the first picture in this thing, and you should probably know what it is. SERES. It's a dwarf planet. Okay, I didn't even know that. It's used as a dwarf planet in the main asteroid belt between Mars and Jupiter. Oh, right, I've heard about these things. All right, so this was a a dwarf planet between Mars and Jupiter. So there's a little floating around thing. It's only 950 kilometers across, which the next size comparison of that is to the moon. We got something else from Pispor here. Let's listen.
Sirius is a binary star system that the Dogon tribe from Africa knew about before we ever looked at it with a telescope. Part of the Great Pyramid of Giza, one of the shafts is aligned to line up with the Sirius constellation.
Yes, I'm just pronouncing it wrong, by the way. So you're right, but I was just pronouncing it wrong. Sirius, you're thinking of SIRIUS, Sirius. I'm looking at CERES. Excuse me. Sorry to cough into the microphone there. But that is so 950 kilometers away. I'm trying to learn kilometers because miles is not what the rest of the planet uses. Sets for here in America. But if I remember correctly, a kilometer. How much? A kilometer. All right, 1 kilometer is a little more than half a mile, right? So it's 0.62 of a mile. 1 kilometer is 0.62 of a mile. So, so 950 kilometers is probably about 500, maybe 550. I'm going to say 550 miles. Let me check. I like to check these things. So 950 kilometers. 590 miles. All right, that's pretty close. All right, so so basically you could split it in half and then add like 10% more, and that's how you can do a conversion, a quick conversion of kilometers. Wow, I'm glad I did this show because I just learned that myself, and now I know how to do the equation. All right, so next up here we have the moon. So we have Ceres, which now we understand is a dwarf planet, which is like smaller than a moon. So that's really a dwarf planet. I guess ridiculously dwarfed. so we have the dwarf planet going to now our moon, which is 350 kilometers, which, if now I'm doing my math, is about 50, would be 15, 17. It's going to be around 2,000 miles. Let's see how close I am with that one. I'm sorry. I'm not going to do this the entire time, but I'm just excited that I can now figure this out. Yep, 2,100 miles. All right, so I keep lowballing it. All right, so there's the moon coming up next. Now, the next thing that's coming up in our video here is Mercury. Now, I just realized yesterday, or I just discovered yesterday, that Mercury is, first of all, Mercury, not Mercury. I'm thinking Mars. All right, so Mercury is the closest to our sun. And let's keep going. 4,900 kilometers. Mars, I just found out, like, and so this is what you're seeing here, is that Mars is just slightly bigger than Mercury. I always thought Mars was kind of like the same size as our sun, but it isn't. It's the same size as Mercury, and slightly bigger. I mean, Mercury's 4,900 kilometers at the diameter, and Mars is 6,800 kilometers at the diameter. So I guess it's Venus that's the same size as Earth, or close to the same size as Earth, but that's really small. I really thought Mars was. So here's Mercury, here's Mars. Oh, I was comparing the moon to Mercury here a second ago. But so there's Mars. Here's Venus. So and Venus is a little smaller than Earth, 12,000 kilometers. And now Earth is coming in at 13,000 kilometers. And again, we're talking diameter. So you can see that Earth is probably, it looks like it's about 2 times larger than Mars. All right, so I like this view right here of Earth. I know this will piss off the flat earthers, but I love this view of Earth where like you could literally be looking at Earth and just seeing the Pacific Ocean, just understanding how big the Pacific Ocean is. Like, look at that sucker, you know? So it's like if you get a certain view of we're going to go back on. We're closing that. Get the TikTok gets very upset when I look at when I put YouTube up. They don't like that at all. So I'm gonna stop doing it. I keep getting shut down on TikTok. But anyway, so you could actually look at Earth and the entire and be looking at Earth from a certain distance in space and literally just see the North Pole and all blue, which is all the Pacific Ocean. So we're at 13,000. Move this way a little bit. 13,000 kilometers, which let's do quick math. Half of 13,000 is about 6,500, right? So 7,000, 8,000 miles is the size of Earth if you want to do that conversion. All right, so now we're coming to Kepler B. Now, Kepler B is an interesting one. Let me pull up some hold on. Get my Googles up. Kepler B. Let's get some information about Kepler B. Kepler B22. Excuse me, Kepler 22b. If I remember correctly, Kepler 22b was one of the exoplanets that we're looking at as a place that we could potentially go. Well, not go there anytime soon, but it was. So let's see. Kepler B is a planet discovered in 2011 that orbits within the habitable zone of its star. Now, it is literally 30,000 kilometers at the diameter. So it's more than double. It's 2.5 times almost the size of Earth. 2.4 times the radius of Earth right there. It says it right there. And it orbits its star every 290 days. All right, so that's about an Earth year. Which also reminds me, by the way, when it always upsets me when I watch like a sci-fi show and they talk about years. Even talking about light years on a sci-fi show. For any alien, anything that didn't come from Earth, they wouldn't use years the same way we do. A light year for any other planet, even our own solar system, is different. All right. So when they're like, oh, we've traveled this many light years. A light year is not a year. A year only makes sense to us because it takes us 365 days to go around our sun. So we use the term year. So a light year for something else, for Kepler B going only 290 days around the sun, a light year is going to be shorter because a light year is a measure of distance. A light year is going to be shorter than a light year on Earth, and it's going to be different for Mercury, and it's going to be different for Jupiter or Uranus, right? Uranus, that's how you correctly pronounce that, right? So anyway, so we're going to keep going through. So Kepler B, again, in the habitable zone, probably has water. It looks kind of weird. It's got a lot of meteor hits, like a lot of circles into it. So it looks like it's got a lot of impact zones. Maybe it doesn't have like a Jupiter type of planet in its in its solar system, right? Oh yeah, rectum. Hey, good morning, Megan. I was kicked off of TikTok, so I'm live on. I just came back because I was trying to show this video that I'm showing now live on my podcast over on YouTube, but TikTok does not like when I show YouTube videos, so it shut me down. So now we're back. But yeah, so we do this, by the way, just as a reminder to everyone, as we have more people joining the show every Sunday, 10 to 12. We do Cosmic Matters. Today we're talking about the size of the universe. We're watching this little video just comparing sizes of planets, and we're going to get to stars. We're going to get to bigger and bigger things as we go. It's only a 5-minute video, and I'm just kind of narrating the video since I can't show it anywhere other than on YouTube. And also, by the way, if you want to check out the show, I post these up on Spotify. You can look up Cosmic Matters, and again, I am Matt, doing Cosmic Matters every Sunday. So next up is Neptune. Just did a flyby Neptune. Neptune also has its own rings. We've discovered it has its own rings. And there was some other interesting things about Neptune. Next up is Uranus. Not Erectum, not Uranus. Uranus, which is about the same size as Neptune. A little bit smaller, but about the same size. And now we get to the big gas giants. So then we have Saturn. Now Saturn is 120,000 kilometers across. Now we've already did the little conversion today. We learned something already, that a kilometer, for those of us in America, is 1 kilometer is 0.6 and a little change of a mile. All right. So if we wanted to see how many miles is the diameter or the equator of Saturn, you're talking probably about 70,000 miles, right? Since this video is in kilometers, and I like to help my American friends where we don't use kilometers, although we should. So here we go. Now we're up to Jupiter. So Jupiter's 140,000 kilometers bigger. Now with Jupiter, I saw I was watching a little interesting fact about Jupiter. I was watching a video with Neil deGrasse Tyson, and they asked him about there was a guy there that asked about the storm, like the red eye of Jupiter. And he was like, why would you believe, like on Jupiter, for example, there's a storm that's been going on for hundreds of thousands of years? Why do you think that that's possible? We're here on Earth, storms only last, very short period of time, like a hurricane, maybe a week at tops, but you're talking about years and years. And he's like, you just don't understand the size of things, right? The Earth is, let me see again. The Earth is 13,000 kilometers at its center, right? At its diameter. We're here at Neptune. Jupiter is 140,000 kilometers. So it's 10 times as big, right? And so now, and how fast it's spinning, and it's made and it's got all this gravity and it's all this gas that's going on. This atmosphere is all crazy. So, and it's spinning. How fast is Jupiter spinning? I like to look this stuff up while I'm talking. So Jupiter spin rate. Let's see. Well, it's maybe if I spelled Jupiter right and not juniper. Jupiter spins faster than any other planet in our solar system. One rotation is just 10 hours. Its equator rotates a speed approximately 28,000 miles per hour, 45,000 kilometers per hour. So that's pretty crazy, right? Because now you have you have the planet that is more than 10 times bigger than Earth, right? Spinning, it takes Earth 24 hours to go around once its rotation, and this planet Jupiter is spinning, and it only takes 10 hours for a complete rotation. So that's moving super fast. Let's see, what's Earth spin rate? I'm just curious now, because you got to move that also on the outside of it. You think of like a ballerina, but not a ballerina, an ice skater, right? If she's spinning, or he's spinning, not to be sexist here. If it's spinning and they put their arms out, right? Their fingertips are spinning around a lot faster than, let's say, their shoulders, right? Because they're further out. So on the edge of Jupiter, how fast that's got to be going past to its core, right? So the Earth, let's see, the Earth spins at 1,000 miles per hour, right? So Earth is 1,000 miles per hour, where Jupiter is spinning 28,000 miles per hour. Holy mackerel. How come? Yeah, I don't know. No one does claim the Earth. Actually, there's a interesting meme. Someone just asked, "How come no one ever claims that the Jupiter is flat?" Probably because we're not on Jupiter, right? There is there's a story I quote a lot on this. I say a lot on this show, but it's basically a Socrates thing where Socrates is talking to one of his pupils, and he says to the pupil, he's like, "Why do you think so many people believe that the sun goes around the earth?" Right? And Socrates' pupil says, "Well, because that's the way it looks. You know, we see the sun rise in the east, and we see it go over our head, and we see it set in the west. So it looks like the sun is going around the earth." And Socrates says to his pupil, he says, "Well, what would it look like if the sun was stationary and Earth was just spinning?" Right? And the answer, of course, is it would look the exact same. But because we value ourselves, so we make ourselves so important. Like even aliens look like us, God looks like us, everything looks like us. If something, the more something looks like us, the more important it is to us. If something looks, a dog is more important to us than a lobster, right? Because lobsters look like alien crazy creatures, and dogs look, they have emotions, and they have puppy dog eyes, and they look kind of like us, right? They look closer to us than a lobster. So a lobster will boil while it's alive and eat it. But if you boiled a puppy alive and ate it, people would go crazy, right? Because it's a puppy. Aliens, no, I mean, lobsters, no problem. Actually, we'll put them in a tank. We'll rubber band their hands and tie them up, and then actually we'll go to the restaurant and pick the one that we're going to eat that day, right? That's totally fine because it's a lobster and doesn't look like us. So yeah, so that's why. So I saw this meme. It was like all the planets of the solar system, and it was like the sun was circular, Mercury was a circle, Venus was a circle, and then Earth was flat, and then Mars was a circle, and all the other ones were circles or spheres, I should say. And well, it was a two-dimensional picture, so circles. But Earth was the only flat one, right? So yeah, people. No one says Jupiter. If we were on Jupiter, then we would say Jupiter is flat. That's kind of how it goes. But we don't want to give credence to the flat Earth people. So just think about Jupiter, man. That's pretty crazy. 28,000 miles per hour. It's spinning, like the speed that it's spinning at, and that's why it can create storms that last for so long. It's 10 times the size of Earth, and it's spinning 2.5 times faster than Earth. That's what creates these massive storms. Pretty cool, huh? So we're learning stuff. I'm getting hearts. Thanks. I know I'm dropping some. There is no way I have 2,300 likes on this already. Is somebody just literally tapping the screen left and right? Is that true? Anyway, thank you. I appreciate it. Awesome. I wish I could play the video that I'm showing, but you can see it on YouTube. Check out Philosophy Man 76. Give me a like there, and subscribe, or you can check me out on Spotify. You can see all this stuff. So Cosmic Matters. All right, let's. It's gonna be a long video. All right, next up after Jupiter is gonna be the Sun. Oh no, it isn't. Proxima Centauri. What is? Oh, Proxima Centauri is the next. If I'm not incorrect, Proxima Centauri is the next closest star to us. If we wanted to go to the next star, all right. So I'm almost positive that's why it's like Proxima Centauri, right? But let's see. I like to double check myself so I don't speak nonsense into this microphone. Closest star to us, and then we can do what I always talk about. Maybe we'll closest star to the sun is Proxima Centauri. Yeah, I like being right. So, all right. So Proxima Centauri is the next closest star to our star, right? It is located approximately 4.24 light years away. It is a red dwarf star. That's why it's so much smaller. It's only, by the way, so it's about 60,000 kilometers, which is about 40,000 miles. Look at me doing quick math now. Bigger than Jupiter. Not even close to the size of our sun. Our star. By the way, our star is not a yellow star. Sorry, Superman. It's a white star. The only reason it looks yellow is when the light goes through the Earth's atmosphere and makes it look yellow. But it's a white star, which I think would make Superman even stronger. If I remember correctly, I think when Superman goes into a white star, he gets like super duper power, super duper man. Is it a Yeti mic? I have no clue. It's a great question. It says Audio Technica. This mic doesn't even go with this mic stand. The mic stand I bought off of TikTok shop, actually. Maybe TikTok will like me more if I promote their stuff. So this mic stand is amazing. The microphone, though, that came with is this one, and this microphone is garbage. So don't use this one. I'm not even gonna say the company, so don't get mad at me. So yeah, I took off my other microphone and I just put it onto the mic stand here that I'm using. So, but let's talk about Alpha Centauri and how far away it is, right? It should be Proxima Centauri. Proxima Centauri. Yeah. Oh, hey, what's up, Grinchface? Oh, it's Grinchface that's talking to me. Great, beautiful. Miss you, Grinchy. I'm on stereo as well, by the way. So Proxima Centauri, 4.24 light years away. So that doesn't seem like it's really far away, right? But let's talk about light years for a second. Let's talk about light years for a second. Let me bring up my factoids. A light year is how far light travels in a year, right? So it's a measure of distance, right? So how far is an actual light year, like in miles? And actually, I can do it in kilometers now too, because now I know how to do the calculation. But how far is a light year? Like how far does light travel in the sense of a year? And the answer is 5.878 trillion miles. Trillion. That's funny. Money Trill just popped. Monty Trill just popped in here, and I'm talking about trillions. 5.878 trillion miles. Now, as I always say, people do not understand trillion. People don't get it. They don't. The millions and billions and trillions. I wish we made the words completely different so people didn't confuse them, because it's like, oh, millions and trillions. Like we talk about, oh, the 1%. The 1% in America. If you're in the 1%, it's the millionaires and the billionaires. No. No. I mean, the billionaires are the point something percent. Actually, let me figure it out. What puts you in the 1% in the USA? All right. So to be in the top 1% in the US, like everyone talks about the 1%, to be in the top 1%, I'm curious. Actually, I got two people in here, right? I got some comments going here. Throw in the chat. What do you think the annual income of somebody who's in that would put you in the 1% in the United States? Curious. I'm curious to what people think. Let's see. Since we're talking about cosmic perspectives here, there's no way I have 3,000 likes. Grinchface and Megan, you guys are doing an awesome job. Thank you so much for all the hearts. I don't need gifts. I'm not trying to make money here, but I do appreciate the hearts. So what do you think? Put in the chat. I'm curious. All right. So, oh, look, you must know this. You definitely knew that beforehand, but you are correct, Grinchface. 731,000 to be more specific. puts you in the top 1%. So when we're talking about millionaires and billionaires are in the 1%, we're not talking about millionaires and billionaires. We're not even talking about 100,000. We're talking about 100,000aires, right? Let's see. What about the 0.001%? Let's do that. So if you wanted to be in the 0.001%, then your income gets to about 60 to 70 million dollars in the United States. That's, I know this. What does this have to do? Well, I'm just trying to put it in perspective. What does this have to do with size of space? I just want to put it our perspective of numbers is just warped because we don't use the proper words. So I'm trying to get to billionaires, right? Let's add another 0.0001%. Let's see. To be in the top, no, I want to be. How dare you, Google? The top one. This is net worth. Why won't you tell me? Why won't you give me the answer? Let's just ask it this way. Billionaires are what percent of the US population? Let's figure it out because it's pissing me off that Google can't figure out. All right. 0.0002% of the population is billionaires, right? So it's roughly 700 billionaires in the population. So where there's about 330 millionaires. Socialist factoids. All right. Yeah, I've seen you doing your shows. Sorry I haven't jumped in. I know if I jump in, I get sucked in for a long period of time. So as far as so we're talking about, so when people say millionaires and billionaires, there's 330 millionaires in America. There's 700 billionaires, right? So again, I like to put in perspective of time, right? If you wanted to count to a million, and for those of you who've listened to this podcast before, you know the answers to these. But if you wanted to count to a million, it takes you 11 days. So 11 days is a long time. It's a week and a half, right? But that's how long a million seconds is. If you want a million, if you count it by a second, no eating, no sleeping, no doing anything else, just counting a million seconds. That will be, that's how long it takes to count to a million. If you want to count to a billion, it takes you. I don't. If you want to count to a billion, it takes you 31 years of counting. That's how much bigger a billion is than a million, right? So a baby is born, and you're like, all right, let's start counting right now. 1, 2, 3, 4. I'm going to count to a billion. On that baby's 31st birthday, when that baby is probably married and has its own babies, you'll be like, oh, happy birthday to you. 1 billion, right? That's when you actually count to a billion. 31 years. 11 days versus 31 years, all right? Now, we were just talking about trillions. We were talking about trillions. A light year is 5.8 trillion. So it's almost 6 trillion miles, right? So how much bigger is a trillion than a billion? Well, a trillion is add 3 more zeros. So now we're going from 31 years to 31,000 years is a trillion, right? So like Elon Musk is going to be the first trillionaire because, that's ridiculous. Let's put that in perspective, how big that is. So, we're in the year 2025. So you're saying from the time of supposed Christ's birth, right, to today, that's 2025 years. So now you'd have to do that 15 more times to get to a trillion seconds. That's how long it is to count to a trillion, All right. So that's quite more than 31 years. All right. So understand. So now we're getting to like the size of the universe, right? As far as this goes. Think of how big this is. What the heck is going on with my heart? I mean, I love it, guys. Thank you so much. I'm at like 4,300. Somebody must have some like a machine that just keeps tapping the screen. Which, hey, I need to buy that machine. I appreciate it so much. So now, so what did we just say? We were talking about alpha. Let's go back to the video here. Proxima Centauri, right? So Proxima Centauri, which is 200,000 kilometers across, just slightly bigger than Jupiter, is 4.2 trillion miles away. Excuse me, 4.2 light years, 4.24 light years away. But a light year is 5.8 trillion miles. So we have to add those. We have to kind of do the math there. So you're talking about 25 trillion miles. 25 trillion miles just to get to the next little Proxima Centauri, little bigger than Jupiter, red dwarf star out there. So when you're looking at like the picture behind me, this is the Eye of God Nebula, by the way. You're trying to run a 5K. Good, yeah. Yeah. Just keep running. Eventually you'll be there. I think I saw a meme. It wasn't a meme. It was a little video of it was a video of like Elon Musk getting off like a spaceship to Mars, and then like David Goggins shows up and he's like, "Yeah, you took a spaceship. I ran here. Go on." If you don't know who David Goggins is, look him up. He's amazing. I might try. If people asking to be a co-host here, I don't know. Does anybody really? Do I really want co-hosts on stereo right now? I don't think so. Only reason I don't want to co-host on stereo is because I can't hear you. If somebody wants to join me on YouTube, I can send you the link. But stereo, unfortunately, doesn't play very well. And my speaker, for some reason with stereo, as soon as I stop the people from going solo, maybe somebody can help me with this. As soon as I try to stop like it calling random people to pull up, now it just keeps making weird noise. Here, I'll play it right now. Actually, here, I'll hook up my speaker.
Battery 60%. Call ended.
So you can keep saying call ended, call ended, call ended.
Call ended.
I don't know why it does that. So oh, you want the link? You want to come up? If you'd have to shoot me an email so I can send you the link. Are you on? If you shoot an email to my Gmail, which is philosophyman76@gmail.com, and I'll send you the link and you can come up. Oh, okay. So shoot me an email anyway. And so that way, yeah, Grinch, I'll love to have you in one of our shows. We had Muhammad yesterday, last Sunday. Super High Man, for those who don't know, he joined me on a couple of the shows. Grinch, I'd love to have you if you'd like to. So, and Megan, you know you're always welcome whenever you get back from Mexico. I have 5,000 likes. Thank you, you two. I know you two going crazy on there. Thank you so much. And and a lot, and actual gifts. I know. By the way, I have the webcam here for it, and so I don't really look down here because if I look down here, then I'm not looking over here, and it makes it for a bad video. So I'm sorry if I'm not looking at the screen as I'm talking and appreciating all my gifts and stuff from TikTok, but I do appreciate every single gift, like, love, and even being here. Oh, good. I'm glad you had a good time in Spain. No, not Spain, Mexico. They speak Spanish, but you weren't in Spain. So where was I? Oh, I was talking about getting to Proxima Centauri. So Proxima Centauri, you're talking 25 trillion miles. All right. So this is like, even when I watch like comic books and stuff, and they're like, oh yeah, this alien flew from here to there. I'm like, these people really don't understand how far and how big the universe actually is. Like we like, oh, they're going faster than the speed of light. Even if you're traveling faster than the speed of light, It's going to take you, if you're traveling at the speed of light, it's going to take you 4 years to get to just the next dwarf star, little Proxima Centauri. All right. You want to go to a different galaxy. We're talking, you're not traveling the speed of light. You're traveling like 10 times, 100, 200, 300 times the speed of light to get to anything else anywhere in our universe. Right. So, all right, back to, I don't know what room he is. Oh, you're not talking to me anyway. All right, so like back to the video. Let's go back to the video. Let's play the video again. All right, so Alpha Centauri, or excuse me, Alpha. I keep saying Alpha Centauri. Proxima Centauri is 200,000 kilometers. The next up is the sun. And then we see how big the sun is. Now, the sun is 1.4 million kilometers across. And so now, if you're seeing this video, you can see all the other planets down here. And you can see why the gravity well of our sun, why our sun is able to have like Jupiter and Earth and these planets circling it and orbiting it, because they're just trapped in the gravity of this giant, huge thing. I mean, remember, Earth is, if I remember correctly, it was 1,300. I keep forgetting. Pretty sure it was 1,300. Mercury, Mars, 13,000. So Earth is 13,000 kilometers apart. This is 1.4 million, 1,400,000 kilometers across is our star. And again, they made it yellow here, but it's not yellow. It's a white star. So I'm glad you guys are having fun over there. So thank you for sharing also. I'm really trying to get the hang of all this stuff. So I appreciate all the shares and the follows and the likes and the loves and that everyone is sharing. So let me keep going. So that's our sun. Now, our sun is pretty big, right? Now, when I say pretty big, it's big, as I said in the beginning, is all relative to the Earth, relative to these things that we have on our the things that we have on our planet. You can actually fit 2 million Earths into the sun, right? Because if the diameter of the sun is 1.4 million kilometers, right, and the Earth is 13,000 kilometers, you could fit about 1,400. No, about 100. It's more than 100, but let's just say 100 Earths next to each other, side by side. If you put all the Earths, you can fit 100 across the diameter, right? Because you take 13,000 and add three more zeros, and you have 100, right? So you're adding. Is it 100 or is it 1,000? I feel like 13,000. Why am I sucking at math? It's my brain is 1.4 million. 1, 2, 3. We'll figure it out. I won't say anything that's not true. Well, anything. I won't purposely say anything that's not true. At least I'm going to call myself out on things. All right. That's 14,000. That is 1.4 million divided by 13,000. Yeah, 107. Yeah, okay. So it's about 107 Earths side by side. Now, if they can go across the x-axis, 100, let's just say 100, going this way, then on the y-axis, you can also, because the sun is a sphere, so is the Earth. So you could go along the y-axis, 100, right? So you could have 100 this way, you have 100 this way, and then you can go across the x-axis, 100, right? So when you do the math on all that, it comes out to like 1.8. I'm just going to round it off to 2 million Earths can fit inside the sun. So the sun is really big compared to us. But the sun is tiny compared to what's going on in the universe. So let's continue with this video. So that's the sun. Now, the next star coming up is Sirius A, right? So Sirius A, which is 2.5 million kilometers, right? So you're talking, let's say 1.4 million miles. And Megan's still trying to run a 3K, right? How far is Sirius A from Earth? Okay, so now we're at 8.6 light years, so double what it takes. Now, that's a star that can actually rival our sun, right? So that now you're talking about a serious star, right? It's is it twice the size of the sun? No. Well, 2.5, 1.4, so it's a little less than twice the size of the sun as far as diameter. But now you're talking, how many Earths can go in there? I'm not going to do the math every single time on these stars, but Sirius A, we can see that star out in the night sky. Somebody said once, so if everything in the universe is traveling around all these bright speed at all these speeds, how come they don't move in the sky? And we're like, they do move in the sky, but they move slowly. And the reason why is because it's 8.6 light years away. 8.6 isn't really a lot of light years, right? Oh, except if you remember that a light year is 5.8 trillion, let's just say 6 trillion miles. So now you have you're talking 6 times 8 is 48 trillion miles away. That's why it doesn't look like it's moving, right? Because if you look in the distance, like when you're driving somewhere and you see like a really tall building in the distance and you're driving, it doesn't look like it's moving. Like you look at a plane in the sky is going 600 miles per hour and it looks like it's moving really slowly, but it's really going 600 because it's so far away, right? So what do you, and what is that? A couple hundred miles up, right? So this is 48 trillion miles away. It's not going to look like it's moving too fast, even if it's moving really, really fast, which it is. All right, so that's Sirius A, 2.5 million kilometers. Next one is Vega. I like the word Vega. I don't know if it's because it mentioned vegetarianism or just because of the Street Fighter character Vega. Wasn't that the name of the Street Fighter character? The claw, like the Freddy Krueger hand. All right, so Vega. Let's find something out about Vega. Vega is the 5th brightest star in the night sky. Okay, interested. Located 25 light years away from Earth, right? So 25, it's pretty close. 25 light years, right? We already did the math on this. 25. All right, so that's 150 trillion miles away. It better be bright so we can see it. So 25 light years away from Earth. So anytime you hear people talking about light years, I just really want you to do that math. I want you to say, okay, a light year is 5.8 trillion miles. And so just understanding that, I think putting that in perspective, because again, we can't talk with all these zeros. But that's just understanding these concepts of how big, how far something over 5,000 likes is ridiculous. Thank you, everyone. I appreciate you guys tapping the screen so much. It's a blue-white main sequence star. I wonder what does main sequence star mean? Let me figure that out. What is a main sequence star? I'm going to do this show just so I can learn more about the universe myself. I don't just share with you guys. We learn for me. All right, control paste. What is a main sequence star? A main sequence star is a star that is stable the longest phase of its life, where it generates energy by fusing hydrogen into helium in its core, right? This process creates a balance between the outward pressure of the fusion and the inward pull of gravity, right? So stars, by the way, the reason why stars are stable is, again, because they're so massive, because Vega is 3.8 million kilometers across, which is approximately, for those of you in America, divide that in half, 1.75. So let's just say 1.9 million miles. So for 1.9 million miles across, remember, the Earth is 13,000. So to break that down to miles is like 8,000 miles across, where this is, millions of miles across, how much mass there is. So there's a lot of gravity, right? There's a massive amount of gravity trying to make this thing collapse. So then there's all this nuclear fusion that's going on that's pushing it out, right? That's stopping the star from collapsing. So the immense amount of energy and heat and light that's coming off this thing. This is why Vega is one of the fifth brightest star in our sky. Okay, because there's got to be a massive amount of energy going on in order to stop the star from collapsing on itself, right? Okay, so main sequence star means a stable star. Now we know that. We're learning today with Dr. Bay. What's up, Doc Bay? Just came into the room over on stereo. So we are on Vega. Vega, 3.8 million kilometers across. All right, let's see what's the next biggest star after that. All right, this video's oh my goodness. All right, so the next one they put up here is Arcturus. So we went from 3.8 million kilometers. Again, one kilometer is 0.6 ish of a mile, right? So you basically in half and add 10%. So this thing is 13, so let's say 14 million miles across. Again, Earth about 8 million miles. Oh, 8,000 miles. 8,000 miles. This thing is geez. So Arcturus, let's find out something about Arcturus. Arcturus. Arcturus is a bright orange-red giant star, the fourth brightest star. Okay, so maybe that's why they're going by brightness. All right, so Vega is the fifth brightest. Arcturus, I can understand why Arcturus is the fourth brightest. Jeez, it's so big. The fourth brightest star in the night sky, and the brightest in the northern hemisphere. Okay, so all the other stars you'd have to see from the southern hemisphere, which is one of the things when I talk to the flat earthers, I'm like, you understand, like, you can't see if the Earth is flat. Why can't we all see the same stars? Like, if you're in the southern hemisphere, you can't see like the northern cross, like the cross. Some of the constellations in the northern hemisphere you can't see from the southern hemisphere, and vice versa, right? So anyway, we'll not give the flat earthers too much time here today, but it is 7.1 billion years old. Wow. Much larger than the sun, 25 times larger than our sun, and located in the constellation, I don't even know how to, Bootes, Bootes, but it's got the two dots, so it must be German or something like that, above one of the O's. The constellation Bootes. Somebody tell me about that. What is the constellation Bootes? You know what? No one has to tell me about it. I have Google. Let's see. Where is the constellation Bootes? I would like to call it Bootes. Bootes is a northern hemisphere constellation known as the herdsman or the plowman. It's best viewed in the spring and summer and is the home of our brightest star, Arcturus. Right? This constellation is associated with the mythological figure of the herdsman or the plowman. who either drives the Ursa Major, the Great Bear constellation, or is credited with inventing the plow. All right. The plow is pretty important. All right. So that's Arcturus. So, I mean, if you're on YouTube, you could see how big this thing is. I mean, that's just insane. And we're going to mention something about now. The sun we can actually still see, but these things just keep getting bigger. All right, here's Rigel. I know about Rigel. Rigel is a blue star. Rigel makes Arcturus look like a little brother, and now we're like the Earth. You can't even see now at this scale. Rigel is 97 million kilometers across. Let's just call it 100. Right. So you're talking about about 60 million miles. Again, the Earth is 8,000 miles. So this is 60 million miles, or at the diameter, just the diameter. We're not talking about going around it. The equator is much longer than that. We're just talking about the diameter of it. So 3 times bigger than Arcturus. Let's find out something about Rigel. I know Rigel is. I've heard of Rigel before. Let me guess. It's the 3rd brightest star in the in the sky. I'm learning. Rigel. Oh no, excuse me. Yeah, I stand corrected. Rigel is the brightest star. It's the brightest star in the constellation Orion, located 860 light years from Earth. All right. Again, how far is light year, everyone? 5.8 trillion miles is a light year. So 5.8 trillion. 5.8 times 860. Is that it? I get to use my chart. All right. So what's bigger than a trillion? All right. Because that is 4.9 bigger than a trillion. What comes after a trillion? Let's find out. So we got millions, billions, trillions. Who knows what comes after a trillion? After a trillion, I actually put out a chart here about it, is a quadrillion. So quadrillion is what comes after that. So we have to start using, which is 10 to the 15th power. So now we're out of the trillions when we're talking about Rigel. And so glad it's that far away, or it would affect us, right? But because these things they're so massive and they're so big, but they're so far away. And to think of a quadrillion, 4 quadrillion miles. I don't even know how long it would take you to count to a quadrillion, right? I haven't looked that one up. We know it's 31,000 years to count to a trillion. Let's see. I'm curious now. Because now we're talking about stars that are 4.98 quadrillion miles away from us. But it's the brightest star we're seeing because it's so big and so bright and so much stuff going on. It's just crazy. So 860 light years from Earth, it is a blue-white supergiant that is significantly larger and brighter and hotter than our own sun. Significantly is a good way to put it. With a mass of over 20 times greater and a radius nearly 80 times larger than our sun. Because it has exhausted much of its core hydrogen, Rigel is at the end of its life. Oh, poor Rigel. And expected to end in a spectacular supernova explosion. All right. Surface temperature is 12,000 degrees Celsius, about 21,000 degrees Fahrenheit for us US people. 21,000 degrees. What's my oven go up to? 600, 700 degrees? Anyway, brightness, it's the 7th brightest star in the sky. So even though it is so much bigger, it's just because it's so far away. Even though it's so much bigger than Arcturus, which is the 3rd brightest star, Rigel, which is 3 times bigger than that, is the 7th brightest star. So it doesn't even beat it in brightness because of the distance. I would assume it's because of the distance, and it's unstable. All right, so let's keep going. What's bigger than Rigel? It can't be. They can't be much more. Up next, oh my gosh. Oh my, one of my friends, a star I really love, Betelgeuse or Betelgeuse is up next as far as the next biggest star. Betelgeuse, just look at the size of Betelgeuse compared to Rigel, compared to Arcturus. Like Betelgeuse that's not even millions, is it? Wait, it's 1.3 billion. That's crazy. 1.3 billion across. So Rigel was about 100 million. So this is 10 times bigger, right? And Betelgeuse, I have a whole video on TikTok about Betelgeuse. Betelgeuse, I already know it's in Orion. It's one of the shoulders of Orion, and is it called Betelgeuse? I need like official. Or is it Betelgeuse? Why do they name these things so hard? It was somebody just like watching Betelgeuse, and they were like, I discovered the star, so I get to name it. So I'm going to call it Betelgeuse because I just like the movie. I'm a Michael Keaton fan. Betelgeuse is a large red supergiant in the Orion constellation. See, I knew that one. Located 520 to 650 light years away. All right, so let's say, wait, why is it 520 to 650? I guess once it gets to a certain size. Like, is it because it's so big that it's that difference? I need to know. It's one of the largest and brightest stars with a radius of 800 times larger than our sun. And we just talked about our sun. And how many suns can fit into Betelgeuse? Let's just get to the nitty-gritty. How many Earths could fit into Betelgeuse? Because we can't understand the concept of our sun. This is fun. I don't know if you guys are enjoying this, but hopefully you are. Beetle. How the hell do you pronounce it? I can't even spell it, more or less pronounce it. How many Earths could fit? Approximately. We're so glad we learned what's bigger than a trillion. There are approximately you can approximately fit 600 trillion to 1.4 quadrillion Earths could fit inside Betelgeuse. Now, this is large range for some reason. Because it depends on the actual, I guess because the star is so far away that they can't measure it with more accuracy. But the volume is so vast that if Betelgeuse were at the center of our solar system, its surface would extend past Jupiter, right? So if Betelgeuse was our star, it would swallow Mercury, Venus, the orbits of Mercury, Venus, Earth, Mars, what is it called? The asteroid belt? Not the asteroid belt, and Jupiter would all be just the star. We would all be inside of, like, that whole space would be inside of Betelgeuse. And so actually one of the things I spoke about once was like, why do we feel like aliens haven't come to Earth? Well, maybe because the aliens are so big. Like, imagine Betelgeuse. With Betelgeuse, imagine the planets. What size planets would be around this? Right? Like, we have Rigel in this picture, right? Look how small Rigel is, like what Jupiter looks like to our sun. So the planet might be so big, and what kind of aliens, what kind of structures under that kind of gravity, under that kind of mass, what size would the aliens actually be? Could those aliens even step on our planet? Like, they would be so big. Like, their spaceship would be like the size. I can't even put it in perspective. I don't even think some of these the beings that came from there would look at our planet and like kick it. I mean, if you really think, again, look at this. I wish I could put this video in rewind, but we can't even see the Earth, the sun, the Earth, the planets. They're not even in this picture anymore. We have to go back like a whole couple of minutes before we get to something even the sun size again, right? But going back here, like look at the size of like Jupiter to our sun, all right? And then we have Sirius A, then we have Rigel. Is right? No, we have Arcturus. That's got to come up now. Vega, excuse me. I forgot about Vega. So Vega, then Arcturus. Like, look at the sun compared to Arcturus. Now look at Arcturus. Isn't even on the picture when we get to Betelgeuse. Like there it is down there. There's Arcturus. Like, so think of the planets that are surrounding this and how big they're the size of Arcturus. Like easily could be Arcturus, but easily could be the size of Vega. Right? Think of all the clouds and dust that had to be in there. So when you're talking about the exoplanets that are around there, how big if life would actually. Why is there inactivity? There's no inactivity. I've been active the entire time. All right. It's saying I'm not active. I'm active, mofos. So think of what the size that aliens would be. Think of like a cell, like just like a cell of one of these things would be the size of like a continent, like Australia. Australia would be the size of a cell of one of these, of a being that had to grow up on a planet of Betelgeuse, right? And then think of how much that gravitational field, like how far away things could be that would be affected by the gravity of Betelgeuse. Like it is just amazing. Like we're just finding it now because Voyager just passed. The Voyager finally just is going on. It's on our way to interstellar space, and what they found is like there's this stuff, these very light. They almost are calling it a bubble, but it's like there's a like an ionosphere that's around our solar system. They think now every star has this like bubble of like particles that surround every star and the solar system and everything else around it, that right now Voyager is going through. It's getting bombarded by this, so they're calling them like space bubble, like star bubbles, in order to go into interstellar space. So think of how far this bubble, how big this freaking bubble would be for Betelgeuse, right? All right. Anyway, I had like 6 of I'm not going to. And thank you, guys. See Grinch Face and Megan are still here, so I appreciate you so much. Thank you. Appreciate you guys sitting and listening to me. Oh, I'm missing part of it. Wait. All right, so now we got some other stars that are just as big that are bigger than Betelgeuse. VY Canis Majoris. VY Canis, Canis Majoris. Where is that? Let's find out something about that star. We're learning about the stars today. I'm getting myself a little education. Why didn't they teach this stuff in school? I guess you gotta. So the problem is I'm not good at math, and math is the language of the universe. VY Canis Majoris is a massive red hypergiant star located in the constellation Canis Major, known for its enormous size and luminosity. It is one of the largest stars known. It's a radius of 1,420 times that of our sun. Okay, now we're getting to points of our brain breaking as far as how big these things are. It would engulf Jupiter if placed in our solar system. Well, we know that because Betelgeuse is the same. It's just slightly bigger than Betelgeuse. And this hypergiant is also extremely bright. I would expect that it would be. And experience powerful solar stellar eruptions that eject significant amounts of mass and contribute to dimming events. No, come on. All right. So distance 3,820 light years. 3,820 light years away from Earth. I don't think we're visiting that place anytime soon. Now, again, the way we can visit these places, we have to go through wormholes. But as far as like traveling there, as far as like Superman flying there faster than the speed of light, if you're traveling at the speed of light, it would take you 3,820 years to get to the star. If you were traveling twice the speed of light, it's still going to take you 1,700 years to get. If you're traveling 10 times the speed of light, it's going to take 382 years to get to this star. Right? So when I watch things, I'm like, oh, it's going fast. It's going faster than the speed of light. I'm like, that's not going to help you. You need to go much faster than the speed of light. And by the way, light travels pretty damn fast. In case you're wondering, I actually have some factoids about this. How fast does light travel? Light travels, speed of light is 299 million miles per hour per second. 299. Let's just round it all off. 300 million. I keep saying thousand. 300 million. Oh, it's meters per second. Okay, sorry, meters per second. Meters are. It's basically 670 million miles per hour. It's 186,000 miles per second. Oof. 186,000 miles per second. 299 meters per second. That makes sense. I guess obviously a mile is a lot more. A kilometer is closer to a mile. Got it. All right. See, again, this is why I'm not a scientist. I'm just trying to explain this stuff in normal terms, right? So, I wonder, in my TikTok stream, it can't be. It looks like it's something. Hey, could one of you two type something in the comment? I just want to see if it's still on. We're still rolling here. Anything, even a check mark or something. It looks like I'm frozen. Okay, maybe there's no more TikTok stream. Hopefully there is. Oh, there we go. Thank you. All right, so I'm not frozen. Thank you for the 5,000 hearts. I don't know how that even happens. How do you guys even do that? So anyway, where or what? Where was the where? You said where? Were you just typing anything and you thought to say where? So we're talking. I was talking about the speed of light for some reason. I forgot. Let's just go back to the video. Let's go back to the video. We are talking about VY Canis Major. All right, next up. Scooty. UI Scooty. Tell me something about UI Scooty. UI Scooty is, I don't even know. What are we getting here? We're at 2.4 billion kilometers across as far as the diameter. 2.4 billion miles across. So again, we get to the point where it's like this, it gets so big that it's like, okay, this is boring to talk about anymore. Because it's just like, oh, it's just bigger and bigger and bigger. And it's like, how is this even interesting? All right. But yeah, it's out there. The UI Scooty is a red hypergiant star in the, who thinks of these words? Scrutum. SCUTUM. Not to be these had to be jokes, not to be misconstrued as the other word that sounds like scrutum. But it's in the Scrutum constellation. I can only imagine what that constellation looks like. Notable as being one of the largest stars by radius so far. Its estimated radius is about 1,700 times that of the sun. And if placed at the center of our solar system, Its photosphere would expand past the orbit of Mars and even the asteroid belt and Jupiter. Right, great. All these are just about the same size in that sense. It's a massive star, one of the most luminous, with a luminosity of about 340,000 suns. I wouldn't suggest you look directly at that star unless you are really, really far away, as we are. How far away is it? Oh, it's only 9,500 light years from Earth. Again, remember, a light year is 5.8 trillion miles. So you got to take 5.8 trillion times 9,500. And I think we've gone to the next step up, which is not a quadrillion. What's after quadrillions? What is after quadrillions? If I remember correctly, it is quintillions. Yes, a quintillion is next, and a quintillion is 10 to the 18th power. So a 10 with 18 zeros. I'm glad you love it. I'm glad we're enjoying this. I did not expect to spend this much time on this one video, but hey, we're gonna have to do a part 2, and then I can have some guests, because I was supposed to have a guest today, but they flaked. So this is pretty cool though. All right, so let's keep going. I'm sure everyone has seen this video on YouTube, but I just wanted to sit and break it down a little bit more, and then maybe we'll do a part 2. We'll definitely do part 2. All right. So, oh, look at this. What is next? Oh, okay. I was just going to get me a star. All right. So next thing is this big black nothing. And if you're wondering what this is, it's called NGC 1277. So, okay. So UY Scuti seems to be the biggest star that was out there. The next biggest thing, it looks like, is a black hole. I'm going to guess that NGC 1277 is a black hole. It might be the black hole in the center of our universe. Our galaxy. But let's see. NGC 1277. By the way, NGC 1277 is 60 billion kilometers across. So 300, maybe 400. Oh, no, excuse me. It's 60 billion. So it's going to be probably 40 billion miles across. NGC is a black hole. NGC 1277 is it's a lenticellular galaxy. What the heck is lenticellular? I've never heard this word. A lenticellular galaxy in the constellation of Perseus. Oh, we like Perseus. I like Perseus, the story of Perseus. He's the one who killed Medusa, right? It is a member of the Perseus cluster of galaxies and located approximately 73. What are MPCs? Oh, we're getting to the MPC. What is an MPC? Not an NPC. So once you start, what does MPC mean? Nope. MPC in distance. All right, I don't. A megaparsec? Is that what it is? Megaparsecs and gigaparsecs. So a megaparsec, astronomers typically express distances between neighboring galaxies and galaxy clusters in megaparsecs, MPCs. A megaparsec is 1 million parsecs. Well, thanks. I knew that. Or about 3,260,000 light years? $3,260,000 light years? A megaparsec, 1 MPC. is 3,260 light years. A light year is 5.8 trillion miles. Brain broken. My brain just broke because this thing is saying a megaparsec. So it is saying that the NGC 1277 is a lenticellular galaxy in the constellation of Perseus. It is a member of the Perseus cluster of galaxies and is located approximately 73 MPCs away. An MPC is 3,260,000 light years, and a light year is 5.8 something trillion miles. I feel like ending. I feel like stopping now. My brain hurts. My brain hurts. It's big. It's not. It's not even. So when we say things are big, what are we talking about? I'm gonna get through this video. There's 2 more minutes. There's 2 more minutes of this video. How much bigger are things? How much bigger? These things aren't even. They're not even. They're not even colored anymore. They're just black holes. No. Wait. Stop. I know we're getting to like galaxies are big. And black holes are at the center of galaxies, which are so black holes. Oh my goodness. Black holes are at the center of the galaxies, which is obviously why the galaxy has all these stars orbiting it. Right? So I get it. They got to be big. Look at this thing. What the heck is ton TON 618? This is 400 billion kilometers across. Is the black hole. Now, we did a whole, by the way, if you want to go to see this, you can go to Spotify and look up, or you can see it on YouTube in my lives. But I did a whole video on, are we living in a black hole? And I believe we are. So this black hole is 400 billion kilometers, which is about 250 billion miles. 250 billion miles across. So yeah, I think we could live in there. We could fit. All right, we could fit our universe in this, right? Because in perspective, what is this to, like, all this stuff could be fitting into a different universe, and that's just bigger than us. And all of our black holes, like this black hole, could have a whole universe inside of it. How much stuff has been swallowed into this black hole and gone to the singularity? Like, it's that far apart, and it goes down to a singularity, and then that singularity, space and time don't exist anymore, and then that goes into a white hole and starts a whole another universe on the other side, right? But we have these. But this thing, what? Tell me something about the time. I need. My brain already hurts. My brain is. It's broken when I found out what a megaparsec, how freaking far that was. Like, I literally have. It hurts. My brain hurts. Right here, it hurts right there. Ton TON 618 is an ultramassive black hole located at the center of a hyperluminous quasar approximately 10.8 billion light years away. $10.8 billion light years away from us is a supermassive black hole. A light year is 5.8 trillion miles. I don't know what a 5.8 trillion times 10.8 billion is. I'm not going to do it because I got to figure out all the zeros. But we've talked about quintillions. So after trillions comes quadrillion, then quintillion. Then after that is what's called a sextillion. Meg? Sextillion. Then after sextillion is a septillion, which is 10 to the 24th power. And then I got a bunch of hearts for pointing out Meg on the sextillion. 10 to the 21 is a sextillion. So it's got to be at least a sextillion, maybe a septillion. After sextillion is a septillion, which is 10 to the 24th power. So 10 with 24 zeros. And then after a septillion is a octillion, which is 10 to the 27. And then 10 to the 30, which is as big as my little chart here goes, is a nonillion. And nonillion. So, which is 10 to the 30th power. So you're going to need that if this supermassive black hole is 10.8 billion. I'm going to do the math, but I'm not going to do it right now. But 10.8 billion light years away, not years, light years. That's just insane. Okay, Mr. Tone 618. What's next? There can't be. How is this video? How is there more? The Cat's Eye Nebula. Wow. So wait, what exactly is a nebula? Because this nebula is that much bigger. It's 250. That can't be trillion, right? Hundreds, 100,000s, millions, billions. It's 250 trillion kilometers across. What the hell is a nebula? What the hell is a nebula? I used these words before, but I don't know what they are. What is a nebula and why is it so goddamn big? A nebula is a gigantic cloud of dust and gas in space. Gigantic. Yeah, that's a good word. I would say that's a good word for something that is 250 trillion kilometers across, which is about 140 million miles. 140. Did I just say 140 million? 140 trillion miles. Big difference. A nebula is a cloud of dust and gas in space. And the word itself comes from the Latin word cloud or mist. Nebulae are often called stellar nurseries because new stars and planets form within them as gravity pulls the gas and dust together. Other nebulae are the remnants of dying or exploding stars, such as a planetary nebula, which are the outer layers of a star shed at its end of its life. Okay. So the Cat's Eye Nebula, let's find out something about that. Other than it's freaking big. It's giant. It's ridiculous how big that thing is. I guess with all that stuff collapsing as it gets pulled together, that's why it's pretty as hell. Look at that. It looks like a blue rose. The Cat's Eye Nebula, or NG6543, is a complex planetary nebula located in the Draco constellation, about 3,000 light years from only 3,000 light years away. Okay. 3,000 light years from Earth. Discovered in 1786, it's famous for its intricate structure of concentric gas shells, which suggest was created by a dying star ejecting material in pulses every 1,500 years. So every 1,500 years, a pulse would go out. So they think this was just a star that exploded. Like one star? Like we're already at, so I guess, okay, so if you got to think about this. So you got to think, so I guess if a star the size of like Betelgeuse or UY Scooty, or some of these bigger ones that we had here, maybe even Rigel. I don't know if Rigel's big enough to do this, but I guess if one of those actually exploded and shot like everything across, then that would, then I guess it could get to this size where like now it's just all the dust and matter that's left over from, but 250 billion miles, like 140 billion miles of this stuff, or 250 billion kilometers. And then it's saying like the petals, like the reason why that is because it was pulsing every 1,500 years, every 1,500 years ago by. Like when I think about like our problem, like the things like we're like, oh no, let's, what's going to happen if Trump runs again in 2028 or this or that, or what's going to happen in the next, like I'm like 2025 years is nothing compared to, we're not going to talk about time because I'm being blown away by space today. We'll talk about the amount of time. We'll do another episode on how long, like giving perspective on how long the universe has been around. But every 1,500 years, just one of these pulses goes out from some star exploding, and it makes the Cat's Eye Nebula, which is really pretty. Anyway, I know my head hurts. It literally hurts. I didn't mean to do this to myself. I thought I was prepared. I thought I was ready. I mean, I've seen this video before, but I just never. Why? Oh, look. Okay, maybe I'll end on this one. Because it's the Helix Nebula. And the Helix Nebula, I think I have behind me. I'm almost positive. Should probably end it on the Helix Nebula. Yes. The Helix Nebula, by the way, is 3 light years across. they just stopped with the millions and billions and trillions of miles and just said it's 3 light years across. So the Helix Nebula is a planetary nebula located 650 light years away. All right, so 650 times 5.8 trillion is how we get to this nebula, right? So this is, by the way, the Helix Nebula, that thing that's behind me. For those of you on YouTube, if you want a better shot of it, there we go. So, right. So this is the Helix Nebula. These things, by the way, that you see like around the Helix Nebula, like up there, over here, those are stars that are not in the Helix Nebula. These are just stars that are in front of it. Because remember, this is like a 3D picture, and this thing is way, way further away than these stars. But I love how this video just said, forget about we're not going to keep putting zeros. It's just 3 light years. It's 3 light years across. This is because, so the Helix Nebula is a planetary nebula located 650 light years away in the constellation of Aquarius, the age of Aquarius, which we're no longer in. It is, I know people, I got hearts from my singing, huh? It's the first time ever. It is 12,000. It is a 12,000-year-old structure of gas and dust left behind by a dying sun-like star. So again, like it's dwarfing my mind to think that stars are making things like, okay, like for those of you that are watching this on YouTube or Spotify, Look how small the Cat's Eye Nebula is. Like, we were amazed by this because this was dwarfing black holes. And then you have this thing that's dwarfing that, and you're telling me that a star did this? Like one star? It doesn't make sense to me. There's a lot of things that don't make sense to me. But this is does not compute. This does not compute. All right. I should just go watch football. It's football. It's okay. We got 11:50. Come on. We can do it. We can do it. Let's just keep going. Oh, that tiny helix nebula. What the hell is this? The old Orion Nebula. I love Orion, right? The galaxy is on Orion's belt, right? For those of you that have seen Men in Black. All right. Yeah, Orion's Nebula makes God's eye look like a. That's pretty though. I like the purple. Orion Nebula facts. Like, I can't believe these are this thing went from 3 light years across to 24 light years across. Now you might go, oh, who cares? It's 3, 7, 8 times bigger. So this thing is 8 times bigger. 24 light years across, not like away from us, but like across 28. So for you to travel across it, 5.8 trillion miles times 24. So let's say 6. So it's going to take you, it's going to be 100 and let's just say 30, 150 trillion miles. Trillion. Not billion, not million, trillion miles. Ridiculous. Tell me something about Orion Nebula. Orion Nebula M42 is a nearby. Oh, it's close. it's a close one. A close nebula. How far is it away? Since it's a nearby one. Oh, you can actually see it with your naked eye. Doesn't tell me how far away it is. Size. How dare they? How dare? Oh, yes. The nebula is only 1,500 light years away. Just a mere 6. 6. What the hell? I don't even know how to do this math. How do you do 5.8 trillion times 1,500? Just a couple of quadrillion miles away. It's close. It's a local. It's right down the street. So this nearby stellar nursery located in the constellation Orion, that makes sense. Approximately, I couldn't have just kept reading. It's approximately 1,300 to 1,500 light years away. Again, right around the corner. It's visible to the naked eye. That's awesome. Yeah, because it's 24 light years across. That would make it visible. It's a massive cloud of gas and dust where new stars, including the young trapezium cluster at its core, is constantly forming. All right, so we can watch some stars being made. This nebula was discovered in 1610. It's one of the brightest nebula and is the closest large star forming region to Earth. So we should go visit. We should head over to the Orion Nebula. Only 1,500 light years away. Just under 6. Just under 6,000. Is that right? 6,000. What is 6,000 trillion? I don't know. The 6 quadrillion, quintillion miles. I think when you say quadrillion, once you get past trillion and you say quadrillion or quintillion, I need to drink something. Like our brains stop. My brain barely understands trillion. You get to quadrillion and quintillion, my brain stops. It's just anyway. Location: the constellation Orion, specifically in the middle of the it's in the middle of the sword hanging from Orion's belt. All right, I'm gonna go check that out because I like looking at the constellation Orion. Thank you, Megan. It keeps telling me Megan sent me a pumpkin latte, but you sent that to me before. No way I'm at 9,000 likes. What the heck are you guys doing? Thank you so much. I appreciate it. That's crazy. I've never had that many likes on a video, so I appreciate it. Appreciate all you guys. Like, subscribe, all that stuff. Cosmic Matters 10 to 12. All right, we got 4 more minutes. Let's finish this. We're not going to finish this. We've got a minute to go. And I guess there's bigger things that we finish. Orion. Actually, we're just going to Orion Nebula, and then what the hell is that? An Omega Centauri. All right, we must be getting to like cosmic, like we must be getting to like galaxy type of sizes, right? Because the Orion Nebula was 24 light years across. This next thing, which makes it tiny, is the Omega Centauri. What the? I got to look it up. I'm sorry, I can't. I just want to just play the video, but I can't. I have no ability to not know what these things are. The Omega Centauri, what the hell is this? It's only 150 light years across. The Omega Centauri is a massive, unique globular cluster. Ooh, that word globular is such a good word. I want to use that more. Globular. It's a globular cluster containing about 10 million stars. Located, it's located 17,700 light years away. I'm not going to even try to calculate that. Remember, a light year is 5.8 trillion miles. It's the most massive globular cluster in our galaxy. Why I just called it? Oh, in our galaxy. Wait, no. Is this all in this? So this globular cluster is in our galaxy, just in the Milky Way? Is that what I'm trying to? Is that what I'm reading right now? Is that? I can't. All right. Is it in our galaxy? It says our galaxy. It is unusual. It is unusual because it contains stars from various ages, unlike typical globular clusters. I just heard of a globular cluster today, but apparently there are typical ones. Unlike typical globular clusters that have stars from a single generation, evidence suggests a supermassive black hole or an intermediate mass black hole resides at its core. So this can't be in our galaxy. Are there multiple black holes in a galaxy? I thought every galaxy had one black hole in it. Am I wrong? Leading to the theory that it may be the remnant of a dwarf galaxy stripped of its outer stars. A remnant of a dwarf. I didn't even know those dwarf galaxies. Wait a second. All right. I didn't expect to feel this way this morning. I expected to go through this with somebody and just laugh at their non-understanding, and now I'm laughing at mine. Can there be multiple black holes? It's hard typing with one hand. Black holes in a galaxy? Of course, the answer is yes. Yes, a galaxy can have multiple black holes. From the countless small stellar massive black holes to ones of more supermassive black holes at the center. Galaxies are thought to contain millions of small. What? Yo, Google is messing with me today. So it is thought that galaxies are thought to contain millions of small black holes formed from the collapses of massive stars, and they often have multiple supermassive black holes, especially after colliding with other galaxies. This is not computing in my brain. Millions of what is a small black hole? Is the TGC whatever thing that was like 2 minutes ago in the video? Is that this ton 618? Is this a small black hole? It's 12 o'clock. I'm tired. I can't do this no more. My brain hurts. I appreciate the people who are here. We're going to wrap this up because I didn't expect this to happen. I didn't expect to be flabbergasted and just do one video. I had like 4 videos prepared and all this other stuff and some Alan Watts, and I'm not going to make it. I can't get through this. There is millions of black holes in a galaxy. Look at this freaking, look, I just fast forwarded the video a little bit. I'm getting mad. That thing was chump change compared to whatever this. So the Omega Centauri that I just talked about that led me down the rabbit hole of there are millions of black holes in a galaxy, where I thought there was one. Well, thank you, Megan, for the heartbeat. It helps my brain, I guess. I just fast forwarded a little bit. So that was that 150 light years across. Then the next thing that pops up is a small Magellanic cloud. Doesn't even have a name. It's 7,000 light years across. Just to go from one end to the other. I can't. I'm tired. I'm like literally getting exhausted from watching this video and talking about these things. What the hell is a small Magellanic cloud? Where are these words? Small Magellanic. I've never heard these things before. Cloud. That's 7,000 light years across just to still be in the cloud. The SMC for short has an average apparent diameter of about 4.2. What the hell is this? This is not. Even though it is a small or so-called dwarf galaxy, the SMC is so bright that it is visible to the unaided eye from the southern hemisphere. You can't see from the northern hemisphere. It's almost like we're on a sphere. The SMC is so bright, it is visible with the unaided eye from the southern hemisphere and near the equator. Many navigators, including, that makes sense, Ferdinand Magellan, who lends his name to the small Magellanic cloud, used it to help find their way across the ocean. Look at that. All right, now that small 7,000 light year across cloud. All right. Okay, come on. We gotta finish. But I just learned something. That was good. The reason why I can't keep going is my brain hurts and I'm not learning new things. And I lost. All right. One more. This is the last one. One more. Oh my God. All right. That's fine. All right. Now I'm okay. Why did it go so fast? What is he doing? His video's going nuts. I wanted to stop. It's the next thing after 7,000 light years after the small cloud is Milky Way. right? And I want to stop there, but then I like went to like the Milky Way is 100,000 light years across. That's one galaxy. We're gonna end at that. One galaxy. By the way, how many galaxies are in the universe? Oh, I thought you left, Meg. People are coming in, throwing me some gifts, and then bouncing. Thank you. I appreciate all the gifts. I really do. How many galaxies are in the universe? All right. So the Milky Way is 100,000 light years across. Remember, a light year is 5.8 trillion miles. And our sun is one of these small little stars in this thing that we're seeing on the screen right now. But as there is estimated to be anywhere from 200 billion to 2 trillion galaxies, things like this in the universe. And it took us this long just to get to this thing, which is 100,000 light years, which is the biggest thing we saw in this video so far. And it gets dwarfed by whatever the next thing is, which is like, what is the next thing? Sorry. Which is the IC 1101, which is 6 million light years across. What is this thing? What is IC 11? It doesn't look like anything. It just looks like a spot. I got to look it up. Sorry, I can't stop myself. I know I was supposed to end. The IC 1101 galaxy is a supergiant lenticular galaxy. This is the second time I've seen lenticular galaxy, so I got to look that up now. Lenticular galaxy. What does that mean? A lenticular galaxy is a type of galaxy with a flat disc-like shape, but without spiral arms. Okay. But we have, so we were in a lenticular. Got it. And it is considered a transitional stage between, sorry, I'm getting tired because my brain hurts. It's considered a transitional stage between a spiral and elliptical galaxy. These contain mostly older red stars and have little to no interstellar gas, which means star formation has largely ceased. For example, examples include the Cartwheel Galaxy and NGC 2787. Well, we have IC 1101 located at the center of the Abdel 2029 galaxy cluster, it's only about 1 billion light years away. Not million, billion light years away in the constellation Virgo. Oh, well, we should end there because I'm a Virgo. It's considered the largest galaxy discovered. Okay, thank God that we're not getting much bigger. No more galaxies. It's the largest galaxy there is. I mean, it's 6 million light years across. I would say it's pretty big. With an estimated diameter of 6 million, with a mass of about wow, are you kidding me? With a mass of around 100 trillion stars, making it vastly larger than the Milky Way. It is also home to an ultra-massive black hole. Could you imagine the black hole? What size black hole is in there? 100 trillion stars. I literally thought with galaxies, I thought the most was like a trillion. I thought like each galaxy was like 100 million to a billion stars. This one said 100 trillion stars. All right, we're done. We're done. That was the biggest galaxy. I'm not going any bigger. I'm tired. Football's coming on a little bit. And you guys haven't been watching the video this entire time. My bad, YouTube. You know what I'm gonna do? since you guys got to listen to me yap on about all this stuff, I'm just going to play the video from right here so you can see all the things I was talking about. Real quick recap. So here's the helix nebula, right 3 light years away. That is the Eye of God right here. This is the Orion Nebula, 24 light years. Pretty in purple. I didn't realize it. This is the Omega Centauri globular thing, 150 light years across, and then that tiny thing. This is now the small Permian Magellan cloud. And then we have the Milky Way, 100,000 light years, and then that tiny thing. And then we have the IC on the left. Oh, I was just going to keep going. This is the Booty's Void. Okay, I'm not going to go into. I'm not looking up the Booty's Void. We're going to stop. We're done there. We're done. I'm not doing the Booty's Void. So anyway, hopefully today entertained your brain a little bit on the size of the universe and all this stuff. When we haven't gotten to the size of the universe, we're just talking about the size of these galaxies and the perspective and all these things that are going on out there. It's just incredible. And it helps put things, I think about this stuff when I had to put my own life in perspective. Like I had things going on, right now my mom got knee surgery and I'm dealing with her recovery and her rehab and whatnot. And, I'm not having issues with my job, but I'm having, second thoughts and of what I could be doing for a living. And when I think about when you think about the time span that we're in, it doesn't make me feel insignificant, but it helps put things in perspective, in that there's so much stuff going on. There's so many, our lifespan is a nanosecond, right? Now it matters, right? This is cosmic matters. It matters because it's us. It's because it matters to us. Everything that does matter, it matters because we make it matter. We make what is important. And so all this stuff I've been showing today, it doesn't matter to a lot of people because they don't think it's important. They don't think about it, and because it doesn't impact their life today. And so I get it. I'm not saying you should think this stuff is important. I'm just trying to entertain you for a little bit, just to get you outside of your bubble, get you outside of your everyday trials and tribulations, and remember what's actually going on out there, and not to take everything so seriously. So it is interesting, right, Megan? So we'll do a part 2 of this. I had so much more stuff I wanted to go over. It's only one video. I got all kinds of stuff I want to cover. And we'll do some Alan Watts next time talking about this stuff. I got 5 or 6 other things loaded up, but this video just encapsulated the entire show today. So, oh yeah, now everybody wants to show up. Right? Every time I'm just about to sign off, everyone shows up on stereo. Anyway, Cosmic Matters. You can check us out on YouTube, Philosophy Man 76. We're on TikTok. We do this every Sunday, 10 to 12. And you can see the show on Spotify. I upload them all to Spotify. This was episode 10. We've done 10 weeks of this. I'm very happy about this. I really, it's helped me as much as it's helped other people, just learn about our universe and ourselves and how we're a part of it. So bye, Megan. Thank you for joining. Bye, Grinch. I don't know if you're still around. Thank you for joining. Thank you, people from Stereo. I'm off to watch some football. And we'll see you next week where we have episode 11 of Cosmic Matters.